Kia ora Year 12 and Year 11. This is a partial fractions question from the November 18 A-level paper. It's a really boring question. Unfortunately though, it's a pattern of question that comes up over and over. The partial fractions part is quite useful for integration. It's the second part that is really quite tedious, and that's where we have to obtain the expansion of f of x in ascending powers of x up to and including the term in x squared. So remember, what we're going to be using for this bit is the binomial theorem with negative powers. So 1 plus x to the power of n is roughly equal to 1 plus nx plus n times n minus 1 over 2 factorial times x squared. And that's as far as we're going to need to go. But this bit here is going to have 3 separate terms in it that we need to do that expansion on. So that's why it gets really tedious. The other thing to notice with the binomial part is that we need to have it in this form where we've got 1 plus something, and then this x in here won't be exactly x usually. Right, so hopefully all of that will come flooding back into your brains once I get into this. First of all, let's look at the partial fractions. We've got 7x squared minus 15x plus 8 over a linear factor, 1 minus 2x, times 2 minus x squared. So when we split that up, we want to end up with a quadratic in the numerator here. So the way we get that to work is like this. We have 1 minus 2x here, and then we have 2 minus x here, a single go at that factor, and then the squared one here. Now this is all done in the A-level textbook, and this is probably the hardest pattern type to remember. The good thing about it is that we have a constant in the numerator for each of those. So where are we going to get a quadratic from? Well, it's going to come when we cross multiply. So this a is going to get cross multiplied with this one here to get a common denominator. The b is going to be cross multiplied with another one of these and then one more of these. And the c will just be, just using a different colour, the c will be multiplied just by this one. So that's going to generate my quadratic. Now, just one more thing before I get into the mechanical part. Just check always when you're doing these that what you've got down here is a cubic, right? So that's order 3. And what you've got up here is a quadratic. So that's order 2. If we had one where we had a cubic over a quadratic, then before we started doing any work on the partial fractions, we would divide the quadratic out, and that would make life a bit easier. Okay, so lots of preliminary stuff here before we get underway. So now what we're going to do is we're going to find a, b and c. We've got 7x squared minus 15x plus 8 is identically equal to a times 2 minus x squared plus b. So I'm looking at this one here. B is over 2 minus x. My common denominator in here is this, this times this. So this is going to be b times 1 minus 2x times another 2 minus x plus c times 1 minus 2x. Now I'm going to put the common denominator in on both sides just because it is a slightly trickier example than some of the basic ones. Okay, so what we're doing here is we're getting a common denominator out of these 3 bits. So that common denominator is going to be 1 minus 2x times 2 minus x squared. So just going over why we're cross multiplying what we are, we've got the a here, it's already over the 1 minus 2x, so it needs to be multiplied through by this bit here. When we turn and we look at b, b is divided by 2 minus x. So it needs to be multiplied through by another 2 minus x and the 1 minus 2x. Lastly, we've got c here, and that's already being multiplied by the 2 minus x squared, so now it just needs that last linear factor there. If this is feeling difficult, that's a sign that you need to do a bunch more practice out of the textbook, because we should have these patterns at our fingertips. All I've got to do now is work with the numerators because the denominators are equal. So we've got 7x squared minus 15x plus 8 is identically equal to this. Now we're going to substitute a value that will make these factors 0. I'm going to use this one here. So when x equals 2, what have we got? Well, we've got 28 minus 30 plus 8 is equal to 0 plus 0 plus c times 1 minus 4. Over here, this gives me negative 2 plus 8, so 6 is equal to negative 3c. c is equal to negative 2. So we've got our first term. Now the next thing I'm going to do is that I can use the value that's going to make this term equal to 0. So we can substitute in x is equal to a half. We don't have to do it that way. We could do it by matching up coefficients and solving simultaneously. But I think most of you prefer to use this method. So on the left hand side we're going to have 7 over a quarter minus 15 over 2 plus 8 is equal to a times, substituting in here, we get 3 over 2 squared plus 0 plus 0. So it's a bit muckier than we like. What have we got here? Well, we've got 8 plus 7 over 4 minus 30 over 4 is equal to 9 over 4a. So let's get a common denominator. 32, take away 30 is 2 plus 7 is 9. So 9 over 4 equals 9 over 4a. A is equal to 1. So the last thing I've got to do is figure out b. But I've got a and c now, so we can use those. So I'll just give myself a little bit more room. Let's just get rid of all of this. So what we're going to do now is we're going to match coefficients. Or in this case, I'm going to match on the constant. So we're going to substitute in the values of a and c. And we're going to look at this plus 8. So we've got 8 is equal to 4 times a, right, looking at the constant in here, plus 2 times b. So I'm just partially expanding this. There's 2b, plus c. But we know a and c. So we've got 8 is equal to 4 plus 2b, and c is minus 2. So 8 is equal to 2 plus 2b, giving me b is equal to 3. So now we've finished the partial fractions part. That's good. Let's write it out cleanly before we start on the expansion. So we've got f of x is equal to a, so 1 over 1 minus 2x, plus b, 3, over 2 minus x, plus c, which is take away 2, so minus 2 over 2 minus x squared. We're ready now to expand this. Remember the question, the second part, asked me to get the expansion in ascending powers up to and including the term in x squared. So that means I'm going to need to get the first 3 terms of each one. I'm going to do this by doing this one, and this one separately, and then I'll add them together. So 1 minus 2x to the negative 1 is equal to 1 plus negative 2x to the negative 1. So not too bad. Roughly equivalent to this. 1 plus negative 1 times negative 2x plus n, negative 1, n minus 1, negative 2 over 2 factorial times negative 2x squared. Cleaning that up gives me 1 plus 2x. This all goes. So plus 4x squared. Right, let's go to the next one. So I need 3 times 2 minus x to the negative 1, which equals 3 times the rearranged version here. So this is 2 into 1 minus x over 2, all to the negative 1, which equals 3 halves. of 1 plus n, negative 1, times negative x over 2, right, so I'm treating this here as my building block, plus n times n minus 1 over 2 factorial times that thing squared. So that's roughly equal to, that cleans up to give 3 over 2 times 1 plus x over 2. Again that goes, plus x squared over 4. It's got 3 terms, 3 over 2 plus 3/4 x plus 3/8 of x squared. Right, the last one is this one here. So we've got negative 2 times 2 minus x to the negative 2, which equals negative 2. And again, I have to do this thing where I have the 1 plus pattern. One, two, three, another one, to the power of negative 2. This is negative 2 times 2 to the negative 2, which is 1/4. Now I'm just left with this expansion. So 1 plus n, negative 2, times negative x. Oops, I've missed out in here, made a mistake in there. This in here needs to be divided by 2. Right, that's that one. N times x plus n, negative 2, n minus 1 over 2 factorial. Right, so you can see, hopefully you can see why I'm finding this so tedious, right? It's just boring. What have I got here? Well, I've got negative 1/2 times 1 plus x. Here, this gives me plus 3 x squared over 4. In case I'm being really careful here, I've got a positive here and a positive here. The 2's simplify out. Right, so cleaning this up gives me minus 1/2 x minus 3/8 x squared. Now I'm not quite done, but nearly. All I've got to do now is, because I've done multiplying through by the constants as I went, I've just got to add up those 3 terms. So we're going back, we're taking this one here, and then this one here, and lastly we're going to add this one here. So f of x is equal to 1 plus 2x plus 4x squared. Line them up in place value order, plus 3 over 2 plus 3/4 of x, and so on. And now we have minus 1/2 x minus 3/8 of x squared. That gives me 1 plus 1 is 2. Then adding up the coefficients here, we get plus 9 over 4x, right, 2 3/4 minus 1/2, plus 4x squared. And that's it, we're done, but it took us 14 minutes of very boring talking. So thanks for watching. I'm betting that no one has actually watched to the end. So if you have, email me and I will deliver some kind of chocolate fish eventually. Thanks.